Hello everyone, my name is Susmita Surakant Patil from SY CSE B Division. Roll number is 206. Today I have explained the topic on the subject is operating system. On the topic is system calls. Firstly, I have explained what is the system calls. The system calls are the operating or the programming interface to the services provided by the operating system. They act as a bridge between user level programs and the OS. The system calls typically written in the high level languages. Like a system calls are usually accessed through the high level programming languages like a C or C++. Programs mostly used in the application programming interface API to access the system calls indirectly. Direct system calls usage is less common because API simplify the process. API is provide the high level way to use the system calls. For example, instead of the calling the Linux read, system calls are directly C programs may use the fread from the C standard library, which internally calls the system call. There are the most common APIs are in the system calls. First is the Win32 API for the Windows. It is used for the writing the applications on the Microsoft Windows. Provide the functions for the file handling, UI operations, memory access, and more. And the second is POSIX API. The POSIX based systems are including the virtually all the versions of the Unix, Linux, and Mac OS X. POSIX API is the Unix, Linux, and Macs. Standard API is used across the Unix, Linux systems. POSIX ensures the portability of the applications across the Unix, Linux, and Mac OS. Java API. Java API is used for the Java virtual machine, and it Java hides the specific system calls and provide the platform independent interface. Example of the system calls. The system calls are sequenced to copy the content of the file to the another file, source file to destination file. There are example of the system call sequence. The steps involved in the system call sequence. Firstly, acquire the input file name. Use the system calls to display the prompt. For example, printf in C, or accept the user input. For example, scanf, which internally use the system calls. And second is the acquire the input file name. Similar to above, show the prompt and accept the input. And third is the input. Open the input file name. Use the system calls like open or fopen if the file doesn't exist, or the terminate the operation. The fourth is the create a output file. Use the system calls to create a new file. For example, create a opening and closing bracket for fopen opening and closing bracket with write mode. If the file already exists, avoid the overwriting. Fifth is the loop. The loop is use the read opening and closing bracket system calls to read the data from the input file. Use the write opening and closing bracket system calls to write the data into the input file, and repeat until the entire file is copied. Display the completion message to the screen, and use the system calls to write a message on the screen. And eighth is the terminate the normally. Use the system calls to exist the cleanly. For example, exist. System call implementation. Typically, a number is associated with each system call. Every system call is assigned to the unique numbers, and the system maintains a table of the system calls indexed by these numbers. For example, if a program wants to open a file, it might call the open the function in C. Internally, this maps to the system call numbers, say 5, and OS uses the number to execute the correct operation. The programmers do not know how the system calls works internally. They just need to use the API like the calling open or read it's called. This makes the programming is easier to protect the OS from the accidental misuse. And the API is the public interface that developers are used. The runtime support the library like a libc contains all logic to handle the system calls behind the scenes. The library is automatically included with the compiler. Here, this slide shows the visual representation of how an application interacts with the operating system throughout the system calls. First step is the user application. User application, a user is programs like a text editor or a browser needs to perform a task such as the opening file. It calls an API function such as a open. And the second step is the system call interface. The API does not perform the task directly. Instead, it communicates with the system call interface. The call is translated into system call's number is I. The number is passed to the kernel using the trap instruction, switches from the user mode to kernel mode. Then, inside the kernel mode, the OS uses the number of I to locate the correct function in its system calls table. For example, number 5 is mapped to the internal kernel function for opening files. The kernel executes the function, for example, implementation of open, which might access the file system, allocate the memory for a check permission. Once the task is done, the kernel returns the control and result, for example, file descriptor or error code, back to the system call interface. This is the passed back to the user application. This is the slide to show the standard C library. For example, how a C programs interact with the system calls using the standard C library. When this is the main idea of this slide. When a C program uses the functions like a printf, it doesn't directly communicate with the operating system. Instead, it uses the standard C library, which then invoke the system calls write. In this case, the C program is calls the printf is greeting. When printf is a part of the standard C library, which is internally calls to the write function. Internally calls the write function. Then the write function is the system calls. In this actually sends the output to the screen file. Then the calls is transition from the user mode to the kernel mode. It is transited by the user mode to kernel mode. And the next slide is represent the how the parameters are passed from the user programs to the operating system during a system calls. There are three general methods used to pass the parameter to the operating system. First is the using the registers. It is the simple and fastest method. The parameters are placed in the CPU register. For example, register is equal to parameter comma the system calls. And the second method is the parameters are stored in a block or a table that stored in the address of this block is passed in the register. It is useful for passing the many or large parameters common in the Linux and Solaris. And the third is the using the stack. The parameters are pushed onto the stack by the programs. The OS pops them up the stack during the system calls. This method is flexible for passing the variable length or multiple parameters. The types of the system calls. The first type is the process control. These system calls deal with process creation, execution and termination. The examples are include the first is the end or abort. This is used to the terminate a process. The second is the load or execute to load and run a program. And the third is the create process, terminate the process. And the fourth is the get process attribute or set process attribute. And the fifth is the wait for time or wait event or the signal event. And the allocate and free the memory for the processes. The second type of the system calls is the file management. These calls are allowed to the programs to perform the operation on a files such as creating, deleting, reading or writing. For examples are create a file, delete file, open file, close file, read, write and reposition, and get and set the file attributes. The third type is device management, request a device and release device, read write reposition, and the get device attribute and set device attribute, logically attach or detach device. The fourth type is the information maintenance. These calls are provide the system related information to the user program, get time for or date, or set a time or date, and the get the system data or set the system data, get and set the process, file or device attributes. The fifth type is the communication. In these calls are facilitate the inter-process communication throughout the message passing and shared. And the examples are include the create, delete, or communication connection, and the send, receive the messages, transfer status information. Example of the Windows and Unix system calls. First is the process control. The process control use the examples are for the Windows. First is the create a process, and in the Unix for, and it is used for the create a new child process. Windows are used the exit process, and Unix is used the exist only, and it terminate the calling process. And the third is the wait for single object in the Windows, and in the Unix only use the wait. It is used the makes a process wait until a child process finishes the execution. And the second is the file manipulation, and in the Windows create a file, read file, write file, and close the handle file. In the Unix open, read, and write, close. It means open a file, close a file, read a file, write a file. In the device manipulation, the Windows are the set console mode, and in the Unix I, I IOCTL means controls the device, and in the Windows read a consoles means reads from a device, and write a console, and in the Unix write to a device. In the information maintenance, get the current process ID. In the Unix use the get paid, and in the Windows set a timer, or in the Unix alarm. In the set a alarm to the for a process. And the third is the sleep, and in the Unix use the sleep, delays the execution for a process for a specific time. And the fifth is the communication. In the communication, Windows are used to create a pipe, or the create a file mapping, or the map view of file means pipe. In the Unix use the pipes, shemget, and mmap. Pipe is the creates the communication channel between the processes, and the shimget is the allocate the shared memory. And the protection, the set file security, initialize the security descriptive, and the set security descriptive group. And the Unix is the ch mode, umex, or the chon. Thank you.